I'm Peter, and I'm going to talk about coding in Solidity. But before I start, I just wanted to ask how many of you are actual developers or coders? Good. Okay, good. So I tried to include in the title that it is going to be very technical. And so it's you will have a double challenge. You have to follow my accent. And also you have to follow a new way of coding. How many of you have Ether or own Ether? Okay, that's good. How many of you seen Solidity code? Okay. How many of you wrote an actual contract and deployed? Okay. So probably you can help me out if I struggle. And a little bit of background of how I got hooked into this whole thing. So I used to be a developer, but very long ago. So long ago, I don't really say I'm a developer. But I was really excited about the blockchain technology and Bitcoin, and we have been thinking about the concept for long, which is a stable crypto coin. So creating a proper money, but in a digital and decentralized way on the blockchain. And that's why we've been following a lot, like very closely, how Bitcoin and the whole ecosystem is actually evolving. And basically, Ethereum made it possible to create this concept without, sorry, just getting into the picture, to create this concept. So I decided, like, I have to refresh my coding skills, because I find the best way to understand something is to actually do it. So learning by doing, understanding by doing is the best way I usually find. So I got head down and I get into like a simple project, a simple game. I figured out a simple game, which, like, okay, that's a perfect game to implement on Ethereum, and very quickly turned out it's not simple. It's super complicated, not because of the game, but because of the way how Ethereum works. And you will hear a lot about that. But anyway, I finished that game. It was really just a toy game, so it works. But very soon moved to implement a proof of concept of our stablecoin concept. Here is the working prototype you can test on the testnet on Ethereum. But I'm not going to talk too much about that. If you're interested, just grab me afterwards and I can explain it in a few words, or you can check on the website. We have a work in progress white paper. So please feel to interrupt me if anything is not clear or you need a bit more explanation. I'm going to just deep dive and give a little bit of overview of what this Ethereum and smart contract thing is, and then jump into some actual coding, so which I will try live on the screen. So basically, what Ethereum provides is a single, how they say, worldwide computer, which is distributed, and it can execute instructions and can store states. State of like data on this distributed ledger. So what basically it adds on top of Bitcoin is, apart from being able to handle like value or data or simple value, basically coins on this blockchain, on this distributed ledger, it's able to execute transactions on this network. And what it gives is basically a trustless decentralization. You are not alone if you don't understand immediately what it means, but actually that's why I came up with an example, and you can get some feeling what it actually means. But it also means that it's very slow and inefficient. So any transaction you execute is going to be verified and executed by every node on the network. So that's the current state. So you can imagine why it's so kind of expensive to run any code on Ethereum. But it has a lot of advantages as well. So you can write these smart contracts, and you can run on this distributed network. And the smart contract is basically a code which can execute transactions and can store data and also can store value, which is Ethereum is basically the basic value it can store, and can execute transactions on that and can verify transactions of these. And what is also very important, these codes are immutable. So once you deploy the code to this network, you cannot change. It's a big advantage. So once you give your money, you give your trust to a smart contract, that smart contract cannot change. At the same time, it makes it very challenging to create something which might need changes and needs to evolve. So you have to think about that when you when you create like a proper live application or smart contract, that think about the upgrades. So in one hand, you can make it upgradable in a way you can change the code for the paper, but it also means that that you are losing the trustless nature of this thing, because you are saying I can change this code anytime. So, but by default, once you deploy the contract, it cannot be changed. You can just deploy a new version or a different contract. And also there's a virtual machine which is developed by for Ethereum. It's EVM they call it, and these smart contracts are running on Ethereum. Does it make sense so far, or just like roughly? Okay. So how we pay for these transactions? So you pay with Ethereum, so that's the currency. But how it's calculated is basically, they call it gas, and this gas is what the miners who are actually checking the transactions, validating the transactions in the network, they are incentivized with this gas. So that's the fee what they get. The gas cost is basically calculated by a gas price and the gas usage of the transaction. And the gas usage is basically how complex is the transaction. Every operation, every storage has a preset value on the network. So that's how it's calculated, how much an actual transaction costs. And what I think for now is important to understand or to remember, so there is a gas limit on this network, which means you have a maximum complexity or size of a transaction. And when you think about this, it's really important. If you design any code or write any code, you cannot have like huge loops or iterations, so very complex code, because it can easily result that it got stuck. The code got stuck because it can never execute because it reaches the gas limit. So and it happened in Ethereum. Actual funds have been lost and logged in contracts and couldn't be recovered because they didn't design properly the code. And you have to remember, storing data is super expensive. Just remember, it's like stored on every node, so it's replicated in every node. So, and probably on a high level, that's what probably a takeaway from this is that remember that you have to think about the complexity of the transactions and how if the data grows and how you iterate and create loops in your code. And also, if you probably it's worth to have a look. It's called Ethereum Gas Station. You can play around and have a look for this. Oh, it's super small, very high resolution. So this is a live. These are like live metrics about this gas status of the network. So if you check that website, you can play around like what is the gas amount, for instance. Your transaction is using, and you can see then how much it will cost, like in fiat money or in Ethereum. So, and you can play about the gas price. So if you increase the gas price, you can see that the fee is going up, but also the expected time is going down for the execution time. So if the higher the gas price, it's more likely the miners will pick it up. So they prefer the more lucrative transactions. Yeah.
What about the mining time actually? When we say the miner will pick up,
yeah.
does it mean that transaction will be mined faster than the other transaction which is having a lesser gas amount?
Yeah, it will be included in the block faster because they will pick up the more lucrative.
It depends on that, like nonce, like what basis the nonce is getting created. So ultimately, like if we are able to find the nonce, indirectly we are saying that authorizing the transaction. So how this gas is linked with a miner who is actually validating, because the algorithm is going to be the same actually.
Yes, so whoever is mining the next block is basically, that's two different things, which transactions are included in the blocks and who is allowed to actually publish a block, who finds the challenge for the block, right? Does it answer your question? Yeah, so it's two different things. So whichever transactions they include and who can actually like publish it in the network, that's two different things. Also,
if the person A and B transfer money from Ether from A to B.
Yeah.
So is it required that if the transaction, the Ether transferred is this much money, then you need to specify this much gas? Is it any correlation in the amount of money which been transferred and the gas in which transferred?
Mm-hmm. So the question is that, is there any correlation between the transaction price and the value what you are transferring? So the answer is, the short answer is no. So it's the gas price depends on the complexity of the transaction. A transfer doesn't matter how big money you transfer; it's always the same. And actually, I think I don't know. It's somewhere here that you can see like what is it like. It's relatively low actually the cost for the transfer. It's a simple transaction. And anyway, here you have like indications of what can you expect of like what gas price you specify and what is the expected time to be executed. Yeah, just probably dig into that after. I will send these slides around, so feel free to take pictures, but probably we can distribute these slides to the people after. So that's about gas. And Solidity. So Solidity is one language. Probably the most popular one, which you can write code for Ethereum Virtual Machine. So, and it's a JavaScript-like language. It has a lot of limitations, obviously, but it's Turing complete, and it's statically typed. So that's a difference compared to JavaScript. So they build that up from ground up. So as I said, it's relatively simple and it has its own little rough edges, but it's constantly evolving. The best way to try, and that will be the tool what I will use for the code today, is there is an IDE in browser, which runs in browser. So basically, you can write code here, you can compile it. I will talk a lot about this, and hopefully it's not too small. Okay, we will work on that. Hopefully I can increase the size. So yeah, so that's Solidity. I wouldn't like to go too much detail in like the Solidity language, but obviously I thought to give a little bit of overview of what are the components of the language. So first of all, variables. So there are state variables. These are the variables which are stored on the blockchain. So whatever is a state variable will be stored on the blockchain and will be stored on all nodes. There's a special kind of thing there which is called event logs. I just emphasize that because that's probably a little bit underutilized in the like for beginners, but event logs are relatively cheap, and the reason that the actual data for the event logs are not stored on the blockchain, only like a special filter, Bloom filter, if anyone knows about Bloom filters, what it does, it's basically it's able to tell if you are querying this index, able to tell if the data is on the blockchain or is the data there or not. So you can query event logs, but to get the actual value, the transaction has to be re-executed, re-evaluated. So it's only accessible for the clients. So if a client queries the event log, then can get the data. And the advantage of this is that it's much cheaper to store like data in the event logs than actually in the state. And there's memory and stack, which is basically variables which they still cost money because the nodes are running it, so it's using the miners memory, but it's much cheaper than to store data on the blockchain. Does it make sense, or any question on this? We'll see examples as well.
If the result of the contract is that some ether is transferred,
yeah.
So is that something different from what you're talking about on this screen?
Yes, it's slightly different, but you can think of the ether balance of a contract. So a contract can have a balance just as like an account, and has an address just like an account. What you might control, or anyone can control an account here. a contract has an address and has a balance as well. So probably a balance is the closest to the state. So because it's stored there, but it's a little bit special also.
So are we saying that contract has basically two things, like one is the contract code itself and there's a invisible wallet attached to the contract actually?
Yeah, we can say like that, yeah. We will see a lot of examples soon, so so you probably get a better understanding when I show by example, but we can say like that, yeah. Cool. Types, data types, just very high level, nothing too fancy. So there are integers, address, there are fixed arrays, dynamic arrays, which are only storage, so you cannot have dynamic arrays in memory, just in brackets. They are super expensive, obviously, because they can grow quite big. Super expensive is like relative, so relatively expensive. And also there are like hash tables, which are mappings, so you can store a key and the value pair in it. They are not iterable, so you cannot iterate on them. So if you need to iterate, then you have to create your own iterable hash maps. And obviously there are structures where you can define your own data types. So, and I will show examples of that, but these are the key types what worth to mention. So, clear? Visibility. So you can set visibility for variables and functions. When you define a variable public, the only difference what will happen that Solidity will generate a getter function automatically, so you can query externally or by another contract the value. You can define internal, which is like the contract itself, and any contract which is derived from that contract can access it. And you can define private, which is only the contract can call or access it. What to remember? I mean, these are really useful and super important for security, for the transactions. But for the actual data, everything is public on the blockchain. So anything you store, can be seen by anyone. So it's really about accessing this, calling those transactions. That's how you leave it. We will see examples of that as well in the code. And function keywords. So it's basically limiting the what a function can do. So you can define there is a view type of function which like won't modify the state. It's just like returns some data, do some calculations, and returns it. There are pure functions which don't even access the state, and there are like external functions which is basically like a public function, but it's optimized for external calls. It's just some internal optimization. If it's not called from within the contract, it's better to define as external. Don't have to worry too much about this, but have to keep in mind when you are creating contracts, because of security, these two things are fairly important, apart from a lot of other security considerations, which I won't go in, but these are the first level of security you have to think about. All right, so what happens with the Solidity code? So you write some Solidity code, whatever tool you use, you compile it, it generates two things, generates like a bytecode through some opcodes. So and also an interface specification. We will see some example for that. So this is like a JSON string which is used by any external tool. So you know what functions and what interfaces that code has. And the opcode and the bytecode is actually deployed as part of a transaction to the chain and distributed to all nodes. And once you deploy it, it's accessible by anyone who can access the Ethereum chain, and also anyone can call any functions, any interfaces what you left open. Yeah.
The bytecode of a contract will be deployed on a one node, or is going to be broadcast and it is going to deploy to all the nodes. So my understanding, initially we deploy to the one node, but we have a facility to deploy to the other node as well, because there is an address associated to the each contract when we deploy to a node actually. And the same node, if the same contract deployed to the multiple nodes, then one contract will not have an idea that the same contract has been already deployed to another node actually.
I'm not sure I followed you, but once you deploy, you obviously interact with one node, but that node syncs to all in like in a peer-to-peer way. It syncs to all the nodes.
Yeah, all the nodes will access, but the actual content will be deployed to one node or all the nodes.
All the nodes. All the nodes. That's why the chain size, I don't know the actual data, but probably 25 gigabytes now. So they are working on improvements on that, but it's growing fast, just like with Bitcoin. But here we have code and data as well, so it's a little bit bigger challenge than with Bitcoin. I have such a nice tool. Do you know this? It's called Coffee. Yeah, this one, and it just keeps the. I just forgot to switch it on. It keeps the screen on. It's for presentations. Okay. Any questions on this? I will show some example, but sense? Cool. We are not going to write any client code. We will interact only through Remix, which is the web-based IDE for contract development, but these are the main ways to actually interact with your contracts. So first of all, as you see, there is an interface specification which comes from the contract. So there are browsers which can access these interfaces. So you can actually call any function of any contract which are deployed to the network through some browsers like Mist or Parity browser, or also there are some other tools you can use, and because the interface is public, then you know what functions are exposed and what are the parameters. Or you can use client apps, and you can write your own client apps. So there is a Web3 API, Web3.js API. That's most widely used. I'm actually experienced with that only, and then you can access any web application using Chrome and MetaMask plugin or an Ethereum browser like Mist or Parity. So I would say perhaps the most common way is for the development, at least, is Chrome and MetaMask, and I talk to some people who are using Parity because they find it better. And yeah, but there are a lot of other libraries and tools to access it. All are in very different state. So ready for some coding? Cool. So I just try to come up with like a simple enough example, and basically it's a very simple naive implementation of a ticket sale. So what the specification, what I came up with, like there's an event, an organizer can launch an event and start to sell that tickets for that event, and people can buy the ticket, and once the organizer closes the event or the ticket sale, basically all the money what went into that contract goes to the organizer. It's probably there are more questions which come up than it solves, but at least we can start to work on that. So let's start with Solidity IDE, and let me try to increase this font size. Is it better a little bit, or can you see at the back? Cool. So yeah, a few words about this IDE. It's changing like every week, so I'm always getting lost in it. So they are working. It's very beta, but basically it's web-based, and it's a fairly good tool to quickly iterate and work on the code. But once you start to work like properly in the project, it's very likely you will use some other tools, which I also used. I did like tell which are those. But for testing out quickly some contracts or quick like manual testing or development, it's getting handier and handier. It still has some rough edges, but getting there. It stores all the files what you work on the browser, so it's in the local storage. So these files, you can save those, but actually it's in the local storage of the browser. And what it